Dear students, welcome back to the lecture on elements of mechanical engineering. Today we are going to discuss about robots. It's a small topic in the fifth module. We have seen robots in movies where we observed the robots can communicate with other robots or human beings and they can do different tasks according to the instructions given by the human. And they can look like human being, they can have hand, legs, eyes, head. Okay, but whatever the robots today we are going to discuss, those robots are different from whatever you have seen in the movie. So these robots are called industrial robots, and these robots are used for industrial applications. They can do some task in the industries, and these robots are different from whatever we have seen in the movie. So here we have the definition for robot. A robot is a reprogrammable multifunctional manipulator designed to move material, parts, tools, or specialized devices through variable programmed motions of performance of a variety of tasks. So this is the definition of robot. So here robot we can program, we can give some instructions to do different tasks or work. According to that the robot will do, and it can do multifunctions also, and it is designed to move the material. It can move the material from one place to another place, or it can move the parts, or it can move the tools, or sometimes specialized devices also we can move through variable programmed motions. It can have different motions or different movements in different directions, and it can perform variety of tasks. So this is the robot. Robotics. Next we have robotics. Here robotics is the field of study of robot. It can be defined as a field of technology that deals with the conception, design, construction, operation, and application of robots. So, here, robotics it is a study of robots, and it consists of the conception. We can conceptualize the shape and size and what the task the robot can do, how it looks, and accordingly we can design the robot in the robotics, and we can construct the robot, and we can make the robot to operate, or it can do the work, and we can use these robots in different applications. This is the robotics. Robots generally possess anthropomorphic characteristics. Anthropomorphic characteristics means human like characteristics. Okay, what the human can do with his hand, the same task the robot can do, and it can possess these characteristics, such as mechanical arm of the robot can resemble the human arm to perform variety of tasks, capability to respond to sensory inputs, communication, interaction, and taking decisions. Here, robot, I told it's an industrial robot. It can have only the characteristic that is the human-like arm, and it can have different motions, whatever the human hand can do, and it can perform variety of tasks, and it can have the capability that it can communicate, and it can see something with the help of sensors. We are going to use sensors in the robot. By using those sensors we can see something in the robot, and we can communicate with the voice sensors, and we can interact with the other devices, or the robot can interact with the human being, and It can take the instructions from the human being and it can do the task, and it can sometimes it can take the decisions also. So this is called the robot and the robotics. Next we have robot anatomy. What is robot anatomy? So we can see here in the diagram. Okay, so here the how the robot anatomy means how the structure of the robot, how the structure of the robot is, and how it is designed, how it can have different parts in the robot. So mainly the robot consists of links and joints. If you take the hand of a human being, okay, so we can have different joints and links. Okay, so here two links are required to make one joint, that we already know. So in the robot also we can have the links and joints. By using link and joints we can have the robot anatomy and it can do different tasks. So here we can observe in the diagram the robot is generally having a base, and the base is connected with a link that is called link 0, and after that there is a joint 1. So here link 0 and link 1 are connected with a joint. Like this joint 2 and joint 1 and link 1 and link 2 are connected with a joint. And finally we have a end effector, so that is used to do different tasks, and by using links and joints we can have different type of motions. Okay, we can have rotary motion, translation motion, or twisting motion. So like this revolving, so like this we can have different motions in the robot arm by using links and joints. So this is called the anatomy of the robot. So now what are all the different joints and links we can have in the robot for different motions? So we have different joints and links in the robot used. So one of the joint is called as rotational joint, or it's also called as or joint. Or indicates rotation. So here we can see there are two links. One of the link is called input link and another link is called output link. These two links are connected with a joint. So this joint can give rotary motion or rotational motion to the output link and input link. This is called the rotational joint. We have another joint. That joint is called linear joint, or it's also called as L joint, and this joint gives linear motion to the two links. One is the input link and another one is the output link. These two links are connected with a joint. This joint will give only the linear motion, whatever the arrow mark shown here we can see. So this arrow mark showing that the linear motion we can have in the output link and the input link is moved. Like this we have another joint that is called orthogonal joint or a O joint. So in this joint can have uh, motion. The motion is shown here. You can see here we have a input link and this is the output link, and it can have linear motion or the orthogonal motion. So here we have another joint that is called twisting joint, or it's also called as T joint. So in this here we have a input link and this is the output link, and these two links are joined using a joint. That joint is called twisting joint. So here when this input link twisting happens, another link with output link will get the twisting. So like this joint can have twisting motion. The joint will get twisting motion. Another one is called revolving joint. We can observe here. Here we have a input link. This is the output link. The output link axis is perpendicular to the input link. So here we can have revolving motion in the joint. So this is called the revolving joint. So these are all the main joints and links used in the robot. So next we have robot configurations. What are all the different types of robots we can create with different types of motions in the robot joints? So first robot, that is the polar configuration, or it's also called as spherical configuration of the robot. So in this we can observe this is the base of the robot and this is the another joint. We can have a joint here, and this is the link, and again here we have another link. So here this can have the rotational motion like this joint can have rotational motion like this, and here also we can have the rotational motion on its own axis, and this link and the joint will give you the linear motion, and again we can have the rotational motion. This is called the polar configuration of the robot, and is only one linear motion in the joint is available, all other are twisting or rotational type of motions. So next, second one, we have another configuration of the robot, that is called cylindrical configuration of the robot. So in this we can see this is the base of the robot, and we have a cylinder which is fixed on the base. On the cylinder we have another uh, joint. Okay, that joint can have the rotational motion or twisting motion here, and it can have linear motion up and down. Okay, so this whole assembly of this can move down, again it can move up. So this is the linear motion, and it can rotate, it can twist also. There will be a twisting joint or twisting motions also, and here we can have a orthogonal motion. Again here the arrow mark we can observe, this is the linear motion, and again we have rotational motion, here also rotational motion. This is called the cylindrical configuration of the robot. So next, third configuration of the robot, that is called Cartesian coordinate robot or Cartesian configuration of the robot. So in this is the base, and we can observe here there are three different axes, X, Y and Z, and here all the joints can have only linear motions. There is no rotation, there is no twisting or revolving motions in the robot joints, only linear motions. Okay, you can see in the x-axis this can have linear motion, and this can have in the y-axis linear motion. In the z-axis also it can move up and down. So this is called the Cartesian coordinate robot. In this only linear motions of the joints are present, no other motions, rotational motion, twisting motions or revolving motions are not present. Fourth one, we have jointed arm configuration of the robot. In this we can see here we have a one joint, here also we have another joint, and here also we have another joint. So here we don't have any linear motions in the joints, only rotational and twisting motions in the joints. By using these only we can do the task. Whatever the different motions we have in the joints, those joints are required, and those motions are required to do different tasks in the robot. So this is the regarding the basics of robots. Okay, so we discussed about what is robot and what is robotics, and what is the anatomy of the robot. Then we discussed the different links and joints used in the robot, and finally we discussed about what are the different robot configurations. Different robot configurations or different types of robots where the robot can have different motions in their joints to do different tasks. So we'll continue in the next lecture about the applications of robots.